So in this video, I'll be reviewing all the different designs that your wonderful textbook has presented. So I won't be just explicitly solving all of them, but I'm just going to give you enough clues so that you can start. Okay. So I don't know, what do you see by looking at this particular problem? The way I see it is that R2, R3 is a subsystem that you want to solve first. Okay. So once you have R2 and 3 reliability calculated, so your system will be simplified into R1 with a parallel of R2, 3, like this. Okay, after you got this, this is nothing but 1 minus chance that R is not working, and also R2 and 3 are not working. So that's the solution strategy. Move to next one. Okay, this one overall, to my view, this looks like a series system. Also, say, let's say this is a, this is also A. They all have the same probability here. Okay, that's good. So you're looking at like a reliability of A. This is bad name. Reliability of all 4 A's, and you multiply reliability of A here. So this is overall the big picture of this design. Okay, when you simplify this part, and this part will be can be considered as a single component, and then it is connected to the this A in a series fashion. Okay, or maybe I should never give the same name here to make the explanation a bit confusing. And then if you consider how do you simplify this AAA, and it's very similar to maybe one of the earlier example we worked on. So you want to simplify these two first. Okay, I don't know whether that's what you see this from by looking at this. A and A in the middle layer, both of them is actually is a series design. This is a series design, so you multiply 95 to 95, that you'll be given the reliability of the middle layer. And once that is done, your system will be looking like this. Okay, your system will look like this. And now you know what to do. You kind of have to simplify this guy as a system with two backups, or redundant parallel. Okay, redundancy is basically backup, isn't it? Anyway, so I'm just complaining your textbook has given a very confusing name. So that's the solution strategy for this problem. This one is not to I don't think I need to mention. This is again a very serious design. And this one, to me, it looked like a parallel design, or parallel redundant design. So you kind of have to simplify all three of them. Those three are series system. All three of them are series system. So you're multiplying 99, 98, 90. That gives you reliability of the upper layer. You multiply 99, 98, 90. That gives you reliability of the lower layer. And that eventually will be simplified into this. And I think you have adequate ability or knowledge to solve reliability for this one. Okay, and is this last one? Oh, this one is also, I'm looking at the subsystem right here, the middle system in here, and this is a parallel, but you have to simplify it. Eventually will become a series design like this. Okay. Yeah, this is a kind of comparison. Again, you're comparing one series design with another series design with the backups. Okay, so I think that you must have sense now that what to do when you try to calculate reliability of product design B. All you need to do is you need to find out reliability here and here, and it becomes a series system with the 4 components. I'm talking about product design B, but R3 and R4, since they have a backup, they will have extremely high reliability. Therefore, yeah. So I don't know what's the answer here. So it looks like this is 998. It's fairly high. I think this will most certainly beat this one. I just don't know whether this can beat this one. Let's find out. Okay, 1 minus 985, 1 minus 0.95. Okay, so it's going to be 1 minus 1 0.015. Wow, this is difficult. And 0.05. Hope I did it correctly. Yeah, so let's take care of this. 1 minus 0.015. Again, I want you to know more than just how to punch numbers, okay? So what's the meaning of 0.015 times 0.05? This is a probability of both are not working. Both are not working. This is not working. This is not working. That's the probability that we're looking at. So we're getting 99925. So this is 0.99925, which is much higher than this. So I think if the question is asking you to compare reliability of two different systems, I'm pretty sure that product design B will give you a better reliability number. That sort of concludes reliability chapter.